Yeah, it used to be in the middle. Why would they do that? That's so stupid. Okay. Unlike in the previous case, the conjugate base of the acid affects the pH when it's formed. Okay, before we had strong and strong, which meant the conjugates were the conjugate bases or acids of strong things, which meant they didn't ever come back together. But now they will, because they're the conjugates of a weak. So we don't do this math. Don't panic on the math here. We just have to know that it looks different. That's why it's sort of a lot more curvy. So here we would have a base that we are going to add to my acid, and we're going to titrate it to the equivalence point here. The equivalence point no longer is exactly 7 because there's weak base included here. So we have a little bit of an issue here. Now, you really don't have to know that much about it besides being able to recognize if it has more of a slope, then we're going to say that it's a weak titration. So the pH of the equivalence point will be greater than 7. Phenolphthalein is a very commonly used indicator in these titrations because it changes colors between 8 and 10. All right, if I was doing it the other way around, coming down here, then I'd use methyl red because it changes around 6 and 5. Universal indicator has a ton of them. Yep, it'll have things that'll change based almost everywhere. But I have the ingredient list. It's like taped to it, so I remember how to make it. But it's like 7 things, and they're like the smallest amounts ever. It's like put 0.005 grams. You're like, I sneeze more than that. Go.
So first one has an obvious straight line.
Yes.
Is there also a straight line on this one?
The end is usually pretty straight. Do you mean flat when you say straight?
I meant straight up and down. Vertical.
Oh, this one still will, yes, have a vertical, but it's a lot shorter. A lot shorter. All right. Okay. Good. Okay. So at each point below the equivalence point, the pH of the solution during titration is determined from the amounts of the acid and its conjugate base present in the particular time. All right, so I'm not going to do the math. I don't want to do the math. Oh, I do have to say something. Because you're gonna be like, oh, you're always the same. We're not going to test tomorrow. But this time, it's different. I'm going to be gone to a track meet on Friday, and I need a sub. But I only need a sub for 20 minutes of this class. So screw that. Just test Friday. No, I don't have a sub. So I'm just moving the test to Friday so I can just walk out the door when I need to. And you can be babysat by Judah.
Just wait, test Friday.
Yeah.
We're moving it to Friday.
I don't know if Judah's ready for that.
All right.
I might not be ready for
Okay, we're not going to do that math. I may come back to it, but I'm not planning on doing it because it's not on your test and it's not usually on the AP test, and it's like 30 minutes that I don't want to spend. No, I don't like it. No, come to class tomorrow. All right. We'll do whatever we don't finish because you guys are talking so much. All right. So here are some different shapes. You'll notice none of them are flat. That's the key. All right. The weaker the acids, all right, the initial pH is higher and pH changes near the equivalence point are more subtle. So that would be nice and flat. Oops, right through here. So we had this change, but then really the equivalence point, we almost got no real change. Ow. Nope, it means it's more basic. It means a higher number. That's one thing that's always weird about pH. Because sometimes, not really an AP, but sometimes we say, oh, it's a higher acid, and you're like, oh, that's a high pH, but no, it's a lower number because it's a negative log scale. It's even hard to write left-fingered. It is, trust me. All right. So all these, this would be strong, strong base, whatever, weak, weak. This would be weak, but not as weak as that one would. That's all. The more gentle this slope, the smaller the Ka value. That's all that's saying. All right, that doesn't matter. Okay, this is the last part of titrations. And once again, there's no math at all for sure on this one. It's just recognizing the shape of a titration with a polyprotic acid. So this acid is H3PO4. What happens is this goes through 3 processes. It goes from here to H2PO4 plus an H plus. I guess it goes through 2 changes, but there's 3 states. It means how many of these there are. So poly just means more than one. Protic means the H. All right, then this H2PO4 can break down. Oh, it was 3. I'm stupid. To HPO4, and there's a second H plus that comes off. And then it can go again, just PO4 minus 3. And then you have another H plus. So it can get rid of 3 different H's. So that happens here. And then you get an equivalence point. Then it breaks off the second one. And you get a new equivalence point. And it breaks off the third. And you get a new equivalence point. It's becoming more basic because we are neutralizing a proton. There's nothing you need to know about them except for their shapes have steps. That's literally it. So if you're given a titration curve on a test, it's like multiple choice or whatever, and it has like that, then you can say, oh, this A, that's a titration of a polyprotic acid. Because it would be like, which of the following is the titration curve for a weak acid, strong base? Okay, and they'd give you that one. You're like, what is that? Well, that's a polyprotic. All right, then you have that, and that's what you would put. And then you'd have this, and that's when you wouldn't choose. You with me? Like the one I made up was a weak acid. So weak acid starts here, and you're adding a base. So it's just going to be pictures, and you choose. A, that's a polyprotic. If it has more than one equivalence point. C would be strong acid, strong base. And this one wanted weak. So we're looking for this piece to be a more gentle slope. Okay, so well, there it is right there. So you would have strong acid, strong base, just looks like that. Weak acid, strong base, gentle slope, still go up, still in flat because we still have strong base at the end. All right, we have weak base, strong acid, so gentle slope, vertical, flat line, and then you have your polyprotic acid. Weak and weak, if you had weak and weak, it would just be gentle, and then it'd be vertical and gentle, but we don't usually do weak and weak because they don't really break apart to take care of each other. It's not one we consider usually.
So the AP test pretty much all math, or is there questions that are like just kind of questions?
There's plenty that are not math, but the free response is pretty much all math. Sorry.
Okay, I got it.
Okay. Multiple choice does have math on it too, but you can't use a calculator. So the answers are like the process
Oh, you can't use a calculator.
on the multiple choice. So like, yeah, you might. So if it was PivNert, and we did one of these before, if it's on the multiple choice and it's a PivNert question, it'd give you like 0.0821, 298, and 4, or something like that. It would give you the setup. You wouldn't have to find the answer. It would give you the setup.
Oh,
That's all. Okay. All right. Friday now for my convenience. And now I love this part. It's called the solubility product. And well, it sounded like an exasperated pencil drop. Okay. It was just a standard pencil drop. We're good. All right. Ksp. Is that a book? Yeah. You use the book? Yeah. To not just weigh your backpack down? Isn't she amazing? How many of you have looked in the book in the last week? Since I gave it to you, raise your hands. You're gonna fail the AP test. Thank you, Leslie. What, Leslie? Sorry. Oh, well, there you go. You can put notes in mine. I should have told you that. Okay. Here we go. Will you write the equilibrium expression for this? The KQ? What would that be? Oh, don't say it out loud. Write it on your fake notes. Here you go. Oh, that was terrible. Sorry. Yes, it's balanced. You should have read the book. No, we've done this. I hate my life so bad sometimes. We've done this 2 billion times. Wait, is this Dooley right here?
Yeah. Give me 2 seconds.
Too much CTE. I played football. I am moderately proud of you as well.
Wait, is this the kind of thing?
Yeah.
Wait, but you don't. Oh no. Cooper, you spoiled it. So I didn't know.
Wow. Well, do you? Nope.
It's just that.
Don't put it over 0.
Okay. Hey, so like David said, you gotta admit that was a pretty good little model.
That was good.
I can't believe it.
What do you do with this? That's the key to Ksp. It's the easiest of all of them because there's never a denominator. So Ksp is Ba plus 2 times SO4 minus 2.
Wait, why is it called Ksp?
It's going to say in a second. It's a solubility product. Because really, this isn't a reaction. It's how it's dissolving. It's breaking apart, right? So it's its solubility. And look at the screen. It's a solubility product. That's where the product comes from. Okay, now, this is even easier. Because remember, we don't include solids. So Ksp is just these 2 things. But look right here. These break down into, for every one of these, I get one of these, and I get one of these, right?
Yeah.
So what do we know about these 2 numbers?
Oh, they're the same numbers.
They're the
Same
same.
amount of holes.
They're the same. So I could just say Ksp is equal to x squared.
Oh, that's tricky.
What?
You should have put that as the answer.
No, they'll ask you math. But yeah, don't, if they say write that, don't put x squared.
Wait, you get a calculator on the test?
Mhm.
So technically, this would be over 1.
Okay, Now, look right here. Yeah, sure, it's over 1, but don't waste your time dividing by 1. Okay, please don't talk. Here we go. Here's the value of Ksp. Yeah, I'm already going to be at the dance. Oh, yeah. Where'd you get that donut? Okay, never mind. I thought it was from Jesse.
No.
Said you're going to use me for my keys, but not bring me a donut. Judah.
Why is it number 1? Is that the initial thing? It's like x2 over I for initial.
That's when we have a denominator, but we're not going to worry about this.
So why is it technically over?
Well, because anything I ever want to write, I can divide by 1. You know, it's not there, but he's saying, can it be over 1? Sure, that doesn't make any difference. It wasn't dumb. Well, his was. Yours was fine.
Yeah.
Okay. Now here's the deal. What is x?
I did. Did I really just get right?
What is x really? Okay. Let's look for it. That's right. X is the concentration of the ions. So what we can do here, if you are given the value for Ksp, you can find the concentration of the ions. If you're given the concentration of the ions, you can find the Ksp. They're really slick. They don't have to be. We're going to do more here in a second. And that's where half of you get way confused. And I don't understand why you get way confused, but that's okay. Solubility products. The equilibrium constant expression for this is this, which we just said. And once again, it's a solubility product because we are multiplying, which means product, the concentration of the things that dissolve. Solubility product. All right. So it's the equilibrium constant for when something dissolves, and it has its own special name, the solubility product. All right. The expression for solubility product does involve stoichiometry. So the one we just did, everything was 1. Are we okay with that? This one, it's not. And I really want you to pay attention here. This is something I've taught for years, and there are kids that never get it. And I don't know how they don't, but whatever. Here we go. BaCl2. If you come down here, the Ksp is Ba. I don't like that. I'm going to write it over here so it's not lower. So it's the concentration of Ba plus 2 and then Cl minus squared. Now we're gonna no, it's not. Here we go. Where did this 2 come from? Okay, good. We got to remember these become the exponents in the product. Okay. So when solving for the concentration of an ion, make sure to account for the subscripts in the formula. Okay, and this is where it gets sort of tricky. Just stick with me for a second. If this was, we got a 1, and a 2, right? If I say that this is an x, what is this? Don't say squared yet. This is just 2x, right?
Yes.
You with me? Okay, so if I have these values, one would be x and one would be twice the value of x. Okay, now watch. If these were x's and they were equal to the concentrations, I now just put them in here and I say x is what Ba would be. Cl would be 2x, but it would also be squared. Now, the reason this is a 2 and that is a 2, they're related, but very different reasons. The square comes because coefficients, the wrong one, I should have circled that one, because coefficients become the exponents in our K expressions. This 2 came because its concentration, we don't know what it is, but we know it's twice as much as Ba. It's twice as much as Ba.
So you're kind of like merging them.
You're right. Both things come together to confuse kids forever. So Ksp is really x times 2x squared, which turns into 4x cubed, roughly. I don't know. All right. What, Tolman? That sounded aggressive, sorry. What part confused you? I can see your face. Here's how I got 4x. Don't, that sounded aggressive too, Reese. Here we go. Take this piece. Just take this piece. Every one of you in here can do that math. What's 2x squared? It's 2 squared, which is 4, and it's x squared, which is x squared. So this piece is 4x squared. And then I multiply it by one more x, so it becomes 4x cubed. Better, Coleman?
What is Ks? Oh, the solubility product. That's what
Yep.
Ksp stands for. And what's Ka stand for again?
That's the solubility for an acid.
Solubility for an acid.
Okay. So when solving for the concentration of an ion, make sure to account for the subscripts in the formula. They're super important. If you don't, you're wrong every time. You're gonna keep that desk? You know, you guys know Micah DeCare?
Yeah.
Micah's sister was sitting like either there or here. I can't remember. It was in the middle. And I was just talking right here. And she got a really weird look on her face. And so I attacked her. Like, oh crap, what was her name? Lily? Yeah. Like, Lily, what's up? Because she was just looking weird. And she's like, my finger's stuck. She'd put her finger in one of those holes. And it was stuck. So, right. So she was gonna have to take the desk home with her. But instead, we have glycerin oil in the back. So she and I, with her desk, went to the back and we just lubed that thing up and it was day fun. Well, don't do it. It was pretty awkward. Don't do it. All right. Okay, find me the generic one with a variable, what this would be. Okay, don't say it out loud, just try it. We're looking for the general Ksp statement of what this would be. That means with x's. What? I don't usually like it, but it was one word. I could pull that off. What bugs me is my shortcuts for my phone don't work on an Apple Watch, which would be really convenient for driver's ed. Because I have like 10 things already. Like if I put 7930, it says, this is your driver's ed teacher, Mr. Davidson. Can you drive tomorrow from 7 to 9:30? Like if it would just work on that, like it'd save me so much time. I know. I'm weird. I'm not. I saw you holding your bumper. I know better.
Well, that means that you just missed out on my teacher, right?
That's, I would have changed your life.
Number ever not be the same? Because if
No.
it's just a focus, it would always be the
Those
same.
are always the same. Okay, do we have an answer? Check with your partner. You can't solve it.
Davidson, can we only do this on this end? You just thought it's okay, I took it back. You're forgiven.
Okay. So here we go. This piece would be mathematically what we need to do first, correct? So 3x cubed is 3 cubed isn't 9. 27.
Oh, it's not 9x, you don't times that, you multiply it.
27x cubed, right? Times what? So that equals? That's the statement. So now look. That actually, I'll bet 7 out of 10 AP kids get that wrong. At least once, at least once.
Oh.
They're like, oh, 3 cubed, that's easy, that's 9. No, it's not. Okay, right. And then the rest of the time, you're like, what an idiot I was. Okay, now, what is this really? So this is what I really want to know now. I want to know the concentration of Al and the concentration of Cl minus if the Ksp is equal to 6.2 times 10 to the negative 4th. Yeah, definitely negative. Sorry about the not negative.
I forgot how to do the.
That's a good, I don't remember that either.
Now it gets rid of.
You might need to scoot side.
Do I have to find like a negative log?
There's no negative log.
Oh, no.
This is the number I just gave you.
Oh.
6.2 times 10 to the negative 4 equals 27x to the 4th.
Oh. Oh, and now I have to find what x is.
You're solving for x.
Do I have to do like
No. Yes.
I don't know how to
a-
find
Oh,
the
this
fourth.
is
I don't remember
I
either.
know where to find the cube root, but there is no four.
Why would you find that? Or could you do it right root square?
Oh. Okay, that's, what did you do to do that?
I can't.
You have to hit my.
Isn't it the same as raising it to the 1/4? That's what I would do.
I did not think about it like that.
Wow, that's actually some big brain stuff.
That's why my skull always hurts. I can barely contain this thing.
Wait, so are we looking for both of them or just?
Both of them.
How to do that. If I can remember these mathematical.
I have an idea. I might have gotten this wrong.
Found it. Oh,
Wait, what
I
is
matched
it?
Sorry.
Caitlin, I love how long it takes you to figure out the calculator.
This is the worst. Office. I don't have to much.
I would invest in just using Davidson.
That's
That's
weird.
Is it?
That's not even investment at all. That's common sense.
Investment of time.
Okay.
Actually, gaining of time. How do you do it?
Are we ready?
Like, yes, 10 seconds.
10 seconds. That will be granted.
What was the number? 27 x to the 4th? Divide by 27.
Do you need it from both of them, right?
I want both. And this is where kids go wrong again.
Oh, I have it from last
Let's see what,
I
three,
solved
was
for
that?
X.
No, Cl minus.
Okay.
Okay, here we go. 10 seconds is elapsed. Technically 23 did. Algebra, here we go. Algebra. We take both sides and divide by 27. Then we take the 4th root of that, whatever that answer was. All right, and so the answer is what? So x is equal to what? Do people agree with that value? Okay,
Yeah. But that should be, that's.
okay. That's x. So the concentration of Al is equal to x. So that's 0.069. the concentration of Cl minus is equal to 3 times X, right? Which is
0.208.
Yeah.
Okay, I did do that, but why wouldn't we square it?
okay, that's a good question. The exponent is used in the Ksp. Please listen, because this is a super good question both people asked. The exponents are involved in the Ksp, but they're not involved in the concentrations. We undid the exponents when we did that, right? So they're gone. All I got to worry about now is the concentration of aluminum is a 1:3 ratio to chlorine.
Okay, that's what I did. I just wanted to make sure because I was like,
Yep, and that's where kids go super wrong here. So if you're dealing with Ksp, finding it or using it, the exponent's important. But once you have just X, the coefficient's the only important part. So remember how Cooper said we're kind of combining them? Well, what we just did here is we took them apart.
oh.
Okay.
Algebra, I can do chemistry.
So wait, if you do just a basic. I'm lost what you call it. How do you do the? Do you get the four for algebra? What would I do first? So I divide by 27.
Yes.
And then you can do the four.
Yep. And I'm pretty sure, once again, raising something, so X to the 1/4, if I remember right, is the same as X to the square root of the 4th. So this is usually easier to type. You put X caret 0.25 versus looking it up on your TI-86 for 10 minutes.
So with this, what I do,
You would take 6.2 times 10 to the 4th divided by 27, and then hit answer caret 0.25.
okay, so your answer, you get by 27.
Yeah, they probably do. I just don't remember where it is. Okay, focus. Here we go. This is probably going to say. This is going to say everything we just said. So you must be able to use Ksp to solve for the concentration of any of the ions. Don't talk. And you must be able to use the concentration of any of the ions to be able to solve for Ksp. All right, so here we go. It's already there, but what is the concentration of Cl minus in a solution of AgCl if the Ksp is that value? This should take you 10 seconds. Yep. Okay. So if it's a 1-to-1, just remember Ksp equals X squared, and X is the concentration, right? So we simply need to just take the square root of that, and that is the answer.
1.5.
Okay, so if it's 1-to-1, remember it's X squared. And then you just square root it, really. Okay, let me, oh, maybe not.
Are you lost on the couch on your phone?
Me? What?
Oh, what were you laughing at?
The Jesse texted me someone he saw with a brand new Lexus today that I know can't afford one. Okay, this is the other direction around. What is the Ksp of silver nitrate if the concentration of Ag plus is 1.3 times 10 to the negative 2? No. Mm-mm. That subscript is not, it's part of NO3.
Oh, so it's just, you just start.
Okay, this one should as well be very, very fast. So it's Ksp equals, it's just 1 to 1, right? So it's just x squared again. So all I need to do, the concentration is x, which is given. So it's just 1.3 times 10 to the negative 2 squared. That would look weird. There you go. And we get what number? Negative 4? Okay, that would be the Ksp. These are not bad, I hope. Let's see here. What is the Cl minus if Ksp for PbCl2 is 6.3 times 10 to the negative 8? Give that your best shot. Soraya, is this just easy or are you lost? I'm worried about you.
Oh, no, I'm good.
Okay. I just haven't seen you write much, which is fine. But if you were lost, I would feel some tinge of guilt. It's a weird feeling I don't normally get.
Soraya's not running and I am.
That's why do you think I was so confused?
I think I switched powers.
Cooper, something else is happening today. I'm getting all the answers right. Something really is going wrong here.
Oh no, I did it wrong. Wow. Oh,
I
you guys
get
got
it.
it wrong? Oh, what's the your question? So is that really Ksp?
Yeah.
Okay, I think I got it.
Okay, I'm going to proceed. Ksp for a 1 to 2, you hopefully remember, is 4x cubed, right? I gave you x and I gave you Ksp and asked you to solve for x, right? So 6.3 times 10 to the negative 8 equals 4x cubed. All right, so first math step you have to do is divide by 4. And then you're going to take the cube root and you'll be ready to roll. Now, I got to check up here to see what exactly it asked for. It wants Cl minus, so we better be careful because Cl minus is really 2x, is it not? Okay, so remember, every time we do this, we're always solving for what one of them is, not the thing with the coefficient that's not a 1. All right, so math, this answer, does anyone have that part? 0025? All right, so that's x. And so really, I need chlorine concentration would be twice that. Fair enough? Okay. We can do these all day long.
I hate when I'm getting things right. I know what she's gonna go.
Oh, we already did one like that.
No, don't say that. This is what I'm doing. That's number done. Don't say that.
All right. Well, there's no data here. Never mind. That was pretty much. So some nerd out there is really struggling in math today. Okay. Will you try this? Do you want it on the bigger screen? It's blurrier on this one anyway. You like that? Now you see where Derek gets all his humor from. You had to be there.
How do people make this stuff? And now
How do they make it?
yeah, how do you
This was determined through experimentation, the relationships,
sound awful?
a long time ago. The answer to how people used to figure this out is that they didn't have phones or the internet. So what else are they going to do? They're going to solve hard problems. No TikTok.
I feel like I would be a very good philosopher.
Yes.
Like people like that had to
Do
like
we
solve
even
real
need
world,
the
like right in their problems. Not-
Yeah, not, does this song match this dance perfectly? I mean, that's a real problem, obviously. Shh, focus. You guys are so close to being focused. This was off the AP test like 5 years ago. It's like the easiest real AP test question I've ever read.
Oh, it's just all you would do is the stupid BB2 times the
Did you just call it stupid?
expert, or not stupid, you know what I'm saying? The expert.
I know what you're saying.
We're given that.
That's like the
We out of here at 1? Okay. I guess it's probably good. I moved it to Friday. Okay, I'm going to go because we're down to 6 minutes. Number 1, write the equilibrium constant expression for the equation. If you miss this on the test, we're not friends. So you'd put Ksp is equal to Pb plus 2. And it's just to the first. You don't have to put that unless you want. And I minus to the second. That's all they want right there. This is a 9-point problem. That's a free point, in my opinion. Number next. There's more, by the way. You're like, that's 9 points? Well, there's more. Calculate the molar concentration of I minus in the solution. Okay, well, it said that Pb is 1.3 times 10 to the negative third. What do I know about the concentration of this compared to the concentration of that? All right, it's a 1 to 2, or I is twice as much as Pb. So that's 2.6 times 10 to the negative third. That's easy money. Yeah.
So on the equilibrium constant, would it be 2i minus or would it just?
On this,
Oh, that's
no.
X minus.
Yep, that's if we make it an X.
Right.
Super good question. Did you hear her? There's not a 2 right here in the equilibrium expression. That's only when we use X.
Oh, yeah.
It's not there, it's here.
By the way, do you guys use a lot of AP, old AP questions?
Yeah,
Because like that's
they're hard to
all-
write.
That's the things that we do, right?
If any of my tests were ever a little bit blurry, that's always been clipped from a real test because my computer doesn't clip them clear. It's annoying.
Or like all the practice, lots of practice runs we go through like
Mhm.
this are all.
Yep. Okay. Calculate the value of Ksp. So Ksp, since it's a 2 and a 1, is equal to 4x cubed. I have x. It's 1.3. All right. So I multiply that by 4. So I have the cube root. No, I don't. What am I doing? That's going the other way. Sorry. I have 4 times 1.3 times 10 to the negative third. And then what do I do? To the 3. Now this would all be raised to the third, right? You're right. You're right. I'm sorry.
I
There.
mean, you could just plug it in for your KSP though, couldn't you? Like when you get the well, when you get the KSP and then you get the I, you could plug in 1.3 into 1.3 times 10 to the negative third into your I is the I.
As long as you square it. Yeah. Where? No. Nope. Because remember, we have the square in the KSP, but this has really nothing to do with KSP. It's just saying, hey, I have $2, but he has twice as much as I have, so he'd have 4. All right. Letter B. Oh, what was this answer?
It was 8.79 to the 10 to the negative 9.
Okay. So we'd say this stuff we would say is not very soluble, by the way. This is a really small number, right? So remember way back in chapter 4, we had the list of the solubility guidelines. Well, the solubility guidelines are based on these numbers. Lead 2 iodide is not soluble because this number is tiny. We did a problem a little bit ago with silver nitrate, which is soluble, and it was to the negative 2. That dissolves. That doesn't. In case you're wondering, way back then. Okay, I love letter B. All right, a saturated solution is prepared by adding it to 2 liters now. What are the molar concentrations of that and that? Justify your answer. So this is a 2-point question right here for sure. Yep. Okay, we're out of time. We got to hurry. What's the answer?
It's the same.
It's the same. It's the same. Something's ability to dissolve, its molar concentration is measured moles per liter. Yes, more will dissolve. In fact, twice as much dissolves, but the volume also increased twice as much. No matter what the volume is, I will always hold 1.3 times 10 to the negative, was it 3? Of whatever. Always, because it is a molar or moles per liter. So a molar concentration is independent of the volume would be your justification. Yeah, and there's some spray that works good. Just use that one, I guess. It doesn't work as good, but it's good enough. All right. You don't know letter C because that's like the 5 minutes I haven't taught you yet. But it's not that hard. Oh, well, you kind of could reason through that if you remember Le Chatelier's principle.